So we're just going to quickly finalize this up by going through some of the properties. So if f of x equals 2 to the x, it looks like, the graph looks something like this. And what do we know? So we know that it is increasing. We know that the asymptote is going to be along there. So see, the asymptote is at y equals 0. And we know that, does this color show up? Probably does. The domain, so it starts at negative infinity, it goes to positive infinity. There's no restrictions on the domain. So the domain is going to be all real numbers. And the range is going to be all real numbers, except that, such that, so that's 0. And you notice it has to be obviously bigger than 0. And because this is an asymptote, over here we have our asymptote, so it never actually gets to this line. So it's never equal to 0, but it's going to be close to 0. So we say that y is a real number such that y is bigger than, but not equal to 0. And that's the range. And one other minor thing, sometimes the y-intercept is interesting. In this case, the y-intercept, how you find a y-intercept? You make x equal to 0. And that's going to be 2 to the 0, which is 1. So that's 1. Okay. Let's do the same things for the other major base graph. Equals 1/2 to the x. As we saw, that kind of looks like something like this. So it is decreasing. The asymptote is y equals 0. The domain is still all the numbers. So x is an element of real numbers. The range actually is going to be the same. So it doesn't quite get to 0, but it stays above it. So whether it's increasing or decreasing, that didn't really affect the range. Y is an element of real numbers such that y is greater than 0. One thing I would like to point out, and we're going to come back to that later, but 1/2 to the x is the same thing as 2 to the minus 1 to the x, which is the same thing as 2 to the minus x. Which is, and if you look at these two graphs, they're kind of been flipped over to y-axis. So it looks like that's just kind of a horizontal flippy-dippy thing there. Okay.